Still, I want to have one last question, because with iPhone lidars, everybody feels like the scanning professional. How would you, like head of the marketing of big SLAM company, how would you tackle this feeling of some people that they can take iPhone 15 Pro or 16 Pro or 17 Pro and just scan their facility?
But again, it's not going to give you the speed that you want, because like you see it, for example, might be useful if you want to scan, let's say, like some small area. But I think that most of customers that buy SLAM scanners, actually they have quite big areas. They have like big facility, big sites. And I think, for example, if you're going to scan with your iPhone lidar, well, you don't have the FOV that you need for just one walk. Because with a SLAM scanner, like in terms of capturing the data, it's really quick. It's like several minutes. It's basically a one walk. But when it comes to using an iPhone lidar, like you still need, like to point it to every corner. And it's like if you have a big facility, and especially if you're going to use this tool in your everyday work, you will just, like go crazy. So, I mean, it's a good, again, that's why I mentioned like different solutions for different workflows.
I think it is the right time to inspire our audience right now. Maybe we can ask Mehdi to join us, Mehdi Boroumand. He's the user actually of FJD products, right? And we would love to see some interesting use cases and how the SLAM scanner can actually solve problem, not just to be a nice thing to have. Welcome, Mehdi.
Well, thank you. Can you hear me okay?
Yes, perfectly fine.
All good. So I really enjoyed what you discussed. I was following every single word that we were discussing, and I've also found some of the gaps that I might be able to fill.
Yeah.
All good. I would really love to address one of the issues that you were discussing about the comparison. As you can see in this picture, this is like a geo toolbox. So one SLAM in my hand, the other drones, other tripods, scanner, virtual tour. It's pretty much like a geo toolbox, which is completed by SLAM scanner. So SLAM scanner is not in competition. As you can see, it's in coexisting situation where to complement the other solution as the actually providing and creating one layer on top of that. So this is me. I'm based in Melbourne. By the way, a little bit about my background. I'm Mehdi Boroumand. This is 40 years ago when I started surveying, as a university freshman. And then I was lucky enough to join the Zeiss, a German company. In 92, I was in the training, and this is 1992. And 98 was the first appearance of the laser scanner. I was the dealer of the Regal. And then fast forward to the present time, I started with SenseFly with the drones. So I was always pretty much in between of drones and the SLAM and the TLS scanners and how to blend those data sets. And you see me flying and launching the multi-rotor drones, scanning the bridge. And then it was 95 when the first SLAM scanner appeared to the market by the GeoSLAM. That was the invention of CSIRO, which is a scientific agency in Australia, who invented the SLAM algorithm. And you see me fast forward with the FJD, and then I will tell you later why I chose FJD. So you see me in the factory, in the several different AEC market, construction, and then I was also joined the Bentley Systems in Australia. But that was just the beginning of a journey, of a very exciting journey, how to blend the data sets from the drone. And you see me here in the CBD of Melbourne, scanning underground, the whole train station, jumping on the boat on Yarra River at the center of the Melbourne CBD, how to scan the bridges and how to convert them to the Revit model. And you see me again launching different types of drones, fixed-wing drones, multi-rotor drones. But it was pretty much requested to do the Scan-To-BIM, if you will. And the problem is that this scanning is just a beginning of the journey, not the end of it. So it's pretty much many misconceptions and misinformation around, as you were discussing and covering some of those. And you see me walking through a project with the SLAM scanner, FJD scanner P2. and then it's just a point cloud, and then the way you convert it to the Revit model. And you see me here in this scene that I'm on stage talking about the digital twin, which is the end goal, a promised land where all data sets, all data will be federated to create and shape the digital twin. So that was the long story short about my background, a little bit sense of my background and what I was doing. So if you play Mehdi one video in the files, that's sharing one of the best Scan-To-BIM projects that I was doing with the SLAM scanner. If you mute the music, please. Yes, thank you. So you see me the drone, actually launching the drone over a site. This is Queensland State in Australia. And the scope was to do some 3D modeling Scan-To-BIM workflow. So I started to fly to capture everything from the top, which could not be seen from the ground by SLAM or any other scanners. So that was covered from aerial, and you see me that I'm landing the drone and taking the aerial imagery, overlap images, leveraging the photogrammetry. And then on the ground with the P2 scanner from FJD. Why I chose this one? Because of the blend, a perfect blend of the 360 imagery with the point cloud. So the point cloud itself, it's not a complete data set because you will end up getting lost in the huge number of points in the space. And even a colorized point cloud, which is one of the deliverables of this scanner, is not good enough to have a good understanding in terms of the 3D space. And if you sometimes you can call it as spatial awareness, as nowadays it's the buzzword. But it's not good enough. We really need to have a virtual tour, high-res, crispy, with the crispy model. And you see two different colors, the point cloud that I'm getting from the drone and how I could, like a cap, on top of this, whatever which was captured. And this is just the beginning of the journey. How do you convert this to the BIM model? And before the BIM model, if you just deliver the point cloud, most of the clients, I can tell you that they're hating the point cloud because it's like a nightmare for them because they just simply get lost. They don't know how to deal with it. They don't even handle it in their computer. What they are really looking for is the deliverables, very clean, 2D or 3D. I know 2D is against your religion, so I'm just focusing on 3D. And this is the end of this story. I can come back later if it makes sense and if you want to review some of those workflows. And that was the end of this story. But I switched back. Sorry, I didn't stop sharing my screen. Could you put my shared screen back in the, yeah, all good. So again, that was not the end of the story. That's just a beginning. And then the virtual, when it comes to the reality capture, the virtual reality is really matters. As you can see on this screen, I'm trying to make it full screen, if it's better. Yeah, so if your audience can scan this QR code by their mobile phone, they will be able to immerse themselves in this 3D full space. They can navigate to different footprints and digitally walk through this whole project. So on the lower left corner, you see the colorized point cloud, which is a little bit fuzzy and not enough to identify actually the thickness or and you can easily get lost in the point cloud when you go deep into the 3D model. And then you really need something like a virtual tour with a super high resolution to have a better understanding, to be able to interpret the features, to replace the point cloud with the 3D solid model. So this link that I've just put in the chat, if you share with your audience, they can click on that link and they can scan this QR code to be able to immerse themselves and walk them through the shared link already shared. So if you just play the next video, which is Mehdi 2.
Just a second. Yeah.
Okay.
20 meters under Melbourne's busiest streets.
A little bit breakdown of this project, which was a really cool project at the center of the Melbourne. This is a very old metro station, which was actually expanded by some developers. It just recently finished, and I was there to scan the existing situation to create an as-built. And you see that I was scanning on the street and underground, and this is a kind of animated section to reveal that what's hidden underground and how to compare with the surface features. And you see that the virtual tour is really providing a blended model of the virtual tour and the point cloud together, which are really essential in terms of understanding the space. So lower left corner, you have the virtual tour. So on the fly or on the walk, when you are walking through such a very confusing and scary millions of billions of point cloud, even colorized, you really need those as this is really a lifesaver and time saver, the way you can have a better understanding of the space. And when it comes to this Scan-To-BIM, you really need to know where to put those solid models and how to replace the point cloud. And one of the deliverables is always our end clients always expect to see some clean, solid models like Revit model or other BIM softwares. So if you just play the next video, that takes us to the next story.
Princes Bridge, Melbourne CBD.
And this is a different story. How I was on the boat, driving the boat, and the purpose of this was to do the bridge inspection. So, I already walked the surface over the bridges, but this was the story how to cover under the bridges. But there was no, as you can see, there is no way to walk through the under bridge. And this is the way how this was converted to the BIM model. So this is really essential point where you can transform the old point cloud to the Revit model, for example, and this is what you can deliver. Otherwise, if you just deliver the point cloud, they just thank you, but this data set will just sit somewhere, and then it will be lost, and they cannot turn it to what they really need in terms of the line works and the maps.
Can I ask you? How did you connect the data from the boat with the data when you were walking about? Because I guess you did not do this in one session scanning, in one scanning session, right?
It was half a day job for me. It was like 3 scans, and then I merged them together. I always started from some known points because I was not using RTK antenna, for example. I just started from a known points as a GCP and on the way, I was also collecting some other GCPs, at least 5 GCPs are required as minimum. And then you can do the georeferencing. But if you're leveraging the RTK PPK antenna, which I'm nowadays using, you don't need those GCPs, maybe one just to check the elevation. And you leverage the RTK PPK on the fly, on the boat. Mm-hmm. I don't know whether I answered the question.
Sure. I would like to also ask you, like, what's your experience with connecting the different scans without the GCPs? Is it even possible to do this with SLAM? Like you do the one cycle, then you do the other. You have some overlapping areas. Does it fit?
Yeah. Trine Model, the product of FJD, is beautifully doing this, and it is called cloud-to-cloud registration. So rather than just collecting some points and very difficult to align them, you just select a bunch of points of the common areas, as you said, and it just does millions of matching. And with how to minimize the errors between all of those, it automatically, with millimeter accuracy, it will deliver a merged point cloud. But again, they just merge together relatively. But if you want to know the location in the real world, you need to georeference them, of course.
Mm-hmm. What if I'm not misunderstood? The FJD has like 2 main series of scanners, right? The S series and the P series. Can you just quickly tell us, like, what's the main difference between those two besides the pricing?
Zolota, you want to go first, or I should do?
Actually, I want you to go first from a user's perspective.
That's why I'm asking you, Mehdi. Like
Yeah.
Right now,
Okay,
I don't
sorry.
care about the FJD answer.
No, I just,
Right now,
yeah,
I want to
okay.
hear
Yeah, sorry,
the
I
user's
misunderstood.
answer.
I misunderstood. That was my misunderstanding. My bad. Sorry. Yeah, there are different classes of the laser scanner. If you want high range, you go for S2. If you need, because S2 has two versions, 320,000 thousand points per second and 640,000 points per second, which is good enough for the mobile mapping, for example, on car. So you have a mount for car or even on the drone. Because of the speed, you really need to have very high rate of the point collection. So that's one of the reasons. The second reason is the range. So the way is, the best practices and the blueprint, if you will, is really depend on the fit for purpose. So this is what you need to plan prior to go to what tools you should pick up and what workflow and the blueprint you should follow. So yeah, that's S2 is the high end, of course, more expensive. The middle level is P2, which is super cool that I was using for some of those projects, as you could see. And P2 is really ideal solution when you need a crispy model and virtual tour at the same time. So you pay much less than S2 because you have lower range. The range is like 10 meters, 30, 40 meters. You don't need more because you don't have the visibility in terms of the line of sight. And you have the latest model of 360 camera on board and super high resolution, which is good enough for crispy virtual tour that you really need for the Scan-To-BIM workflow. Mm-hmm. And the lower end, which is a very good, very low cost solution, which is an entry level. So the virtual tour is not as good as P2, but it is called V4E. And the cool thing is that you can detach the GPS receiver, GNSS receiver, and you can use it for normal GNSS point collection, and then you can attach it to the scanner, and that's really saving a lot of money because it's like hybrid. The GNSS, the same GNSS, you can use the pointer, laser pointer, and collecting the points can be attached to your scanner for direct georeferencing.
But is the same GNSS the smaller one like on the P2, or
No.
is it the big?
No, it's more sophisticated because it can be used independently. That one that you just pointed out, which is a mini size, it's only designed for in integration with the scanner. But this one that I was talking about, which is V4E, is independently can be used independently. So it's like hybrid.
Do we have some videos or pictures of this? I would like to see that.
If you just visit the website fjdtryon.com, or if you can share.
I'm there now. Yeah.
Okay, if you go to the products and you will see V4E LiDAR. V4E LiDAR.
Okay, I can see that. Okay, I will share the screen.
Oh, good. I didn't prepare because I'm not using it yet.
No worries. Okay, so we're here.
This one is super cool. I just ordered a few of them for some of the other projects because it's very low cost. I don't know anything more inexpensive than this one. And if you go back to the hardware, yes, this is good. So you're literally using your mobile phone rather than having a super expensive virtual tour. I mean, 360 camera, you're using your own phone. Of course, you have to, if you need the full colorized point cloud, you have to also change the direction to cover by your mobile phone because it's not 360. But this can save you a lot of money in terms of the 360 camera. The other thing is that you don't have to use the mini RTK. You're using the independent GNSS receiver. Detachable.
Okay, so is this run, right? You're
exactly.
To? Okay.
This can be used independently, which is equipped with the IMU and the laser pointer also. So it's fully independent GNSS receiver. You can pick the points. And then when it's needed, you can attach it to your scanner, and it's automatically converting to the georeference laser scanner. And the expensive is unbelievable. I'm not sharing any figure with you, if Zlata, but you can find out later that it's super, super inexpensive.
Zlata, could you give us at least some range of the pricing of this?
Yeah, actually, can you hear me, right?
Yeah.
Yes.
Yeah. So actually, the pricing differs according to the package that you want to buy, because you can buy it with RTK module, and as Mehdi mentioned, actually you can buy it without RTK module. For example, if you're going to use it only indoors, and the price will slightly differ, but it's like under 3,000.
Yeah. So if you allow me, I would love to diversify some of the use cases to cover more verticals if the time allows.
Sure.
So if you put my screen back in the shared, yeah, all good. So I wish to continue with a totally different use case, which is the forestry. So this is me in one of the forests that I was asked to do the 3D modeling for tree analysis. So you see me walking through those trees.
Could you
trajectories.
Mehdi probably put it on a presentation mode? It will be full screen for the viewers.
Okay. Is it better now?
Yes, perfect.
Yeah.
All good. So you see me walking through this forest, and you see the trajectory that I was walked. Actually, I walked, and then, well, trying to cover. It's like mission planning is pretty much similar to the drone mission planning. You just need some lines and then coverage and overlapped areas. And then you can also check the gaps on the fly. So on your mobile phone, you have the real-time point cloud, and you can check whether or not you covered everything. So as you can see, this is one of the parts of this big forest. And then I go to the tree analysis, and this is really cool. The possibilities of one of the specialized module in Tri-Model. So Tri-Model, you have different specialized modules. One of them is forestry, which is super cool and very, very actually equipped with the different tools you need to do all analysis, which normally for the resource management, for the forestry, you name it, which is related to the natural resources. Everything is available there, of course.
Can I ask you, Mehdi, why did you pick straight lines for the path? I could see on the videos before that you went like back and forth on several like parallel lines. I don't know why, but I would probably like pick the zigzag path.
Yeah.
Like just going,
Yes.
So is there any difference in that, or?
Probably you're smarter than me. This is the first reason. The second reason is that I was trying to control the situation, not to leaving any gaps behind. So what was in my mind was like a mission planning, what I learned over the years from the drone operations, trying to have some parallel lines, to be mindful, not to be, because when you walk zigzag, you can easily prone to leaving gaps behind. Okay. So it's really difficult to check the gaps in your mobile phone, because under the sunshine and the harsh environment, it's very difficult to check every now and then the gaps, what you have left behind. So the one of the main reasons was to control, not to cover everything and not to leave any gaps. That was the reason.
Since you mentioned
that
sometimes
it's like, yeah, okay, go ahead.
You mentioned that there is a specific module in the software for forestry. So what kind of analysis, what kind of interesting data can you get out of there?
Actually, you can classify the trees. You can, depending on the type, there is a big library of the different trees with different types. And this is really the very specialized area, which I'm not
So it can actually recognize the type of the tree?
Exactly. Every and each single tree can be classified independently. And the other elements, like the thickness of the trunk, or measuring different measurements, those experts need different measurements to estimate the volume of the mass. They call it biomass. They even measure the canopy, the crown. So they do a different analysis, which this module providing them the tools and the analysis they need. And you can see the different colors. which is really connected to the library, and you can also add some new trees to the library.
What's
So
your
that's a huge
experience?
area.
Because right now you are showing almost perfect grid of the trees, right? But the
Yes.
usual forest doesn't look like that. So what's your experience like in the real forest when you have parts that are very dense, for example, and you have like several trees next to each other with their crowns going through each other? How does it work in such an environment?
Yes, of course, it's really going wild in that situation. This is more regular because this was for a research project. That's why they just planted there like a grid. It's not like a walled forest. It's not like a natural forest, let's say. And yes, I've been in those situations. I haven't prepared the video of those, which is very wild, and even walking is very big challenge. You always struggle to walk there because it's very steep and very hilly situation and very difficult. You can easily trapped in between the bushes and also the trees. So it's really more challenging, and yes, very heavy lifting job to do.
Mm-hmm.
I can tell you.
How would you control the data? Because we mentioned earlier that you usually need to like close loops when scanning with SLAM. And when I'm thinking about a forest, I think of a environment that where it's quite difficult to find some open space,
Yes. Yes, I
somewhere where
normally
to place
use.
reliable
Yeah.
GCP, you know, and
Yeah, actually, well, that RTK enablement is really lifesaver in terms of the georeferencing, in terms of the connection, and also even the registration part. This is it is also completed by PPK as well in P2. So if ideally, if you have RTK PPK, you are free from GCPs. But even if in that situation, to control the situation in the wild forest, in the natural forest, my approach is always the parallel line to control the gaps and the coverage. And I normally use an app on my mobile phone to navigate in that situation where it's really difficult. All of the trees look similar. So you can easily get lost in between trees. And I normally use an app on my phone, which is called Handy GPS, which is one of the typical navigation app. And I normally track myself on the fly, but of course I need to get the signal from the GNSS. And nowadays, because of the different constellation and huge number of satellites, the chance is very high to you get the signal even under heavy canopy, which you do not see the sky. You can still get the signal.
okay.
Okay, if you allow me, I prepare something more in terms of I'm trying to diversify the number of use cases. This is another story of the bridge inspection. And then I will highlight why the virtual tool playing very crucial role here. So you see me walking under this bridge, which is on the highway, but the purpose was to actually identify the cracks on the concretes. And so I'm walking on the bridge. This is done by P1, the first generation of the FJD, which is discontinued right now. And that time and you see the trajectories. This was also completed by the drone because I was very into the drones. I always love to complete, no matter what, complete by the drone, just to make sure that I cover everything and nothing's left. And you see the culvert underneath the bridge. It's like a small tunnel. I was walking, and on the other side, I put the trajectory intentionally to just highlight that how I walked the project. And this is matrix 4E, which was flown over the project to create a crispy model, whatever which can be seen from the above, and which was hidden actually. And I try to actually correct the geometry by blending the point cloud I got from underneath it, and how to correct the geometry of the mesh I could create by the Bentley software. So this was really the first test, how I could correct the measurement by a different source of point cloud when you blend the point cloud and push. And this is the comparison I'm trying to highlight in this part. by this section. This is the green got from, I couldn't stop. I should have stopped it to compare that. So the green section was from the drone, which was really melted under the bridge, but it was complemented by the scanner. And then how I could blend those and correct the reality mesh, the 3D mesh. So eventually I got the super crispy with the correct geometry underneath and over the bridge. And the virtual tour was essential here, how to actually run an AI detector for crack detection. So the crack detection was done automatically by AI, which was trained by some AI detectors was trained by the images and started. I just ran the AI detector over this bridge to identify and extract the cracks out of the concretes.
Is this AI detection also the feature of FJD Dynamics software?
Not yet. I used another software
to
run the AI detectors. I used the Bentley solutions because they had the AI detectors in place. So I actually ingested and consumed these data sets to the Bentley solutions just to be able to run the AI detectors for the crack detection. That was the purpose of this project. So I go to the next one. This is industrial application. This is a different story, very scary environment. So again, I always blend. I always love to blend from the above and from the underground. So underground, you see me with the pole. This is extension pole. So because having a spatially dominating on the assets and all machinery, and this is a big factory of manufacturing for some oil and gas parts. And I use the pole to extend and also provide more access to the different locations. And you see how I'm playing in different direction on pole. This pole is available for P2 and S2 as well, but the company is working for the small one. And you see how is it super light? It's only 1 kilogram plus minus a few grams because of the pole. And you see I have used a wristband. I put the mobile phone on my wrist rather than putting on. So you see that to providing the visibility for real-time check of the point cloud. So you see that I'm using just a wristband of the sports people that they're using for the sports. I used the same to attach my mobile phone on my wrist, and I'm just.
That's very clever.
Yeah. So when you are struggling with this harsh environment, your brain starts functioning much better, and you get smarter. So again, this was covered also from the sky, as you can see, and the end was beautifully blended. The point cloud I got from the drone photogrammetry and blended and aligned with what I got. So I've covered all indoor.
Sorry, Mehdi. Mehdi, do you align it and blend it in the FJD Dynamics software or somewhere else?
Yes, in FJD software. This is the result.
So you just bring the data from the drone in what, like LAS format or something like that?
Exactly. And
the LAS format was the then match them based on GCPs or just cloud to cloud, or how do you match them to?
Cloud to cloud. Cloud to cloud is much easier and much faster. So I got the point cloud as the deliverables, one of the production of the photogrammetry software, drone photogrammetry software. I got it from Pix4D Mapper. You can even get it from the AGSoft Metashape. So they just export the point cloud and just import in the trial model and blend with whatever you processed from the scanner. And because they are both point cloud, they're in the same world, so you can easily play with them and then extract the very exceptional value by bridging those instruments. So the scanner is just not only in the competition; it can be in the friendship and in line with other and co-play and coexist with the other gadgets as well. How they can beautifully complement each other. So again, back to the workflow and the blueprint you developed. And sometimes you do this on your own. I've done this by different because in every project, I try to push the boundaries in terms of what if scenarios. So what if I do this and that? Let's see what happens. And it's really exciting when you can, as a learning curve, how you can develop and push the boundaries. So that was an industrial application. So what do I have next? Would be a mining, which is very typical, frequently used cases. And you see me walking on the piles and the stockpiles. These are huge mine sites. And I'm simply walking. This is the purpose was the volume calculation, and they are doing this every day. They're changing the volumes, and they need to have full visibility in terms of the volumetric calculations. And I was there to do the proof of concept, how they can easily do this, but just simply walking the whole site, and how they can easily do the calculation and get the report, and Tri-Model beautifully doing this and exporting very clean Word report out of those stockpile volume calculation.
Does the software from FJ Dynamics allow also for meshing? Like, can you create
Yes.
the 3D mesh from the point cloud?
Yes, beautifully. And they have two algorithms for this. The mesh can, for example, if you are talking about a function where you have for one z, you have one x. You mean it's as a function, you for each x, y point, you need to have one unique z, not more. This is, as I call it, function. The example could be like mine site. For each x and y, you only have one elevation, not more. But when it comes to some closed and confined spaces, like the tunnel, like underground, you have more than one z value, for example, for tunnel. That's why Tri-Model has two different algorithms to create the mesh for tunneling, for example, or for mining, for example, which is just a surface. And this is the report, how it's the clean report that you can export as a result of this volume calculation. So the answer to your question is yes, and even different types of the mesh, not only just one generic mesh.
And does it also produce the texture on the mesh? So the final mesh
Yes.
is like actually with colors and everything else, right?
Well, if you're talking about the
or is it just a
polarized,
surface
texturized
for
mesh? Yeah, we can export the mesh like PLY, for example, and you can import in other third-party softwares.
Mhm.
But in terms of the texturized mesh, which is like a drone actually exporting, it's not as good as the drone, because drone has high-res imagery as well. Here we do not have overlapped imagery like the drone.
No. I understand the quality issues, because these are coming from very different sensors, and SLAMs by nature have bigger noise. So I understand that the 3D mesh will not be as clean as from photogrammetry, for example. But still, my question was like, for example, if you do the industrial plant, right? You do the scan. Can you create the colorful 3D mesh out of it?
And what is the purpose of this question? What are you looking for in terms of the deliverables? Perhaps I can.
I want an
answer
OBJ file to be used somewhere else.
The answer is yes. It can export OBJ. It can export BLY. It can get the reality mesh like a thin model of the surface, if you call it a triangulated irregular network as a mesh. But it's not colorized or super with the texture.
I wanted to
it's not texturized.
Okay.
All good. So this is a different scenario. This is a cave story. This would be my last story of this collection. Here we were asked by the natural resources, and also this is in the Middle East, not in Australia, and this is a group of mountain climbers and cave climbers, and this is P1. My colleague is going and I'm outside with the drone, my favorite toy. So while my colleague was doing scan, I was doing the drone. This was Mavic 2 Pro at the time. So I was collecting those imagery to have the full coverage of the mountain above the head, and also inside. I connected, as you can see, I connected the whatever SLAM captured with the the super crispy mesh model of the whole mountain. And by this, you can really solving so many mysteries. For a mining, I was there, and when I blended those data sets, they could solve so many mysteries. One of them was like this fault from the geological perspective. Sometimes they would love to follow some cracks or faults, and to see that what is the relation between these faults and our mine, to improve the safety and to mitigate the risks. For example, in such hazardous environment, they need to have a full understanding, multidimensional actually awareness of the site. And this was, of course, this was a cave, but this could be underground mine, for example, which is safety is first always. And that was the final story. And well, when it comes to the scanning with the virtual tour, and then this was actually, I prepared this slide to highlight the fact that how much the virtual tour is essential to have a better understanding, because when it comes to the Scan-To-BIM, you really need to identify the features around you, and by point cloud, you are simply drowning in the millions of points. And without this, as you can see, as a result of the virtual tour, you have no clue what you're looking at. And that was the end of my part of sharing stories.
Perfect. Thank you so much, Mehdi. It was very insightful, and I'm always happy to hear stories and showcases from actual users, not only from the company, because companies, they always want to speak nice about elephants because they want to sell them. But it's really great to have actual user and speak to him and see their use cases. So thank you, Mehdi, for joining us and for
Pleasure.
this.
Pleasure. The question you didn't ask, though, the question you didn't ask why I chose FJD among those very noisy market with different brands. Why I chose?
Maybe I didn't want to know that. No, but since you touched it, go ahead. Tell me why FJD.
The reason was, one of them was, again, the virtual tour, the ideal virtual tour, and how it's calibrated and blended with the laser scanner in the same environment, perfectly aligned. Virtual tour was an essential tool to have a full visibility. The second was the team is really committed behind the scene. So it's not only a matter of the equipment, also the people behind the scene, and not only the branding, the people who are dedicated and who are committed to guarantee and also your full success. The success matters for them. The sale is just the beginning for them, not the end of it. The third reason is that the software is unique among those other manufacturers. Actually, looking at the wrong. They're focusing on the wrong subject. They're focusing on the scanner itself very much, and they simply miss this fact that the software behind this is running, the processing the whole data sets, and actually creating those deliverables is even more important than the sensor. Because I can tell you that, so most of the customer, they know who's the manufacturer of the laser head, and what is the SLAM code in GitHub. Some genius students, they can even access the coding part, the algorithm from the GitHub. So the putting together, integrating, that's not the big challenge. The big challenge is the way the people committed to the actually their vision, the vision which is resonating with what you're looking for, and the commitment of the software. The software is there is a big team who are developing, and the way they are just publishing the new versions, I cannot really catch. Every week they publish something as the new version upgrade, and they just keep adding the new tools and evolving the whole solution. That was the reasons I chose this one.
Even though I didn't want to ask that question, I actually thank you for answering this bit, because the points you just mentioned are valid in general, not only for FJD. Because when people ask me like which SLAM solution they should buy, I always say, don't look at the data sheet. Okay, they are more or less all the same in terms of hardware used. What's important is the software, it's the support, it's the learning curve, it's the learning support, whether they have some courses and everything else, like what outputs they allow you to do from the software, what plugins do they offer for other softwares, right? So look at what's coming after you scan something. Don't look at the design of the device and how beautiful the datasheet is. Actually care about what's becoming after, or what's happening after you buy the SLAM solution, because that's where everything changes, and that's what actually matters. Thank you, Mehdi. See you later. Thank you, Mehdi.
Thank you. Yeah.
And we are continuing with Zlata.
Yeah.
You have some more use cases. I'm really looking forward to them.
I think that in terms of completing the visualization part of the workflow and communication with stakeholders, especially non-technical stakeholders, I think that result is already going to be enough for most of our workflows that we cover.
For my impression from this discussion, that you want to avoid the topic of 3D Gaussian splitting, this is pretty impressive.
Yeah, it actually looks like a video, right?
I think it looks really good. So great. Can I play the other one?
Yeah. It's also another video of 3DGS that we made several days ago.
Thank you so much, Zlata, for doing this.
Yeah, thank you for having me, Michael.
Sure. Thank you guys for watching this. Sorry it took almost 2 hours, but I hope it was valuable. I really had a great time with Zlata and Mehdi here. I hope you guys had a great time too, and see you next time. Thank you.
Yeah, thank you.